Welcome to The Explainer. Today, we're diving into something, well, it's a truly radical new idea in quantum computing. We're talking about a technology that basically takes the rulebook and just tears it up. So let's kick things off with a pretty wild question, because it gets right to the heart of this new architecture. The Recursive Quantum Collapse Engine, or RQCE for short. This is an idea that, and I'm not exaggerating here, could change everything we think we know about building these incredible machines. Okay, so to really get why this is such a game changer, you first got to understand the arch nemesis, the number one enemy of pretty much every quantum computer out there today. You know, the dream of quantum computing, it's all about perfection, right? Perfectly stable qubits doing their thing in this silent, isolated little quantum world. But the reality? Oh, the reality is so much messier. We're talking about constant environmental noise, instability, and this one big boogeyman called quantum collapse. That's the moment when that delicate quantum maybe state is forced to make a choice. It snaps into a definite yes or no, and poof, your whole calculation can just get wiped out. So right now, every major player in the quantum game is basically in this all-out war against collapse. It's a battle of brute force. You've got these gate-based systems, for example, and their plan involves using millions of physical qubits just to shield and protect a few stable, usable ones. Think about that. It's this massive, incredibly complex shielding operation. For everyone, the enemy is collapse, and the name of the game has always been to fight it, delay it, suppress it, anything to keep it at bay. And then, this new architecture, RQCE, just waltzes in and asks this beautifully simple, almost absurd question. What if we've been looking at this completely backwards? What if the enemy isn't the enemy at all? What if it's our greatest ally? Okay, let's really unpack that, because this one idea, it changes everything. Forget building bigger and better shields to protect the quantum state. What if you could actually harness the very thing that's supposed to destroy it and turn it into the engine of the computer itself? And that is the Recursive Quantum Collapse Engine. It's a totally new class of quantum computer. It doesn't fight collapse. No, it uses it. It intentionally triggers these controlled, repeated collapses, and then, here's the genius part, it uses the information it gets from each collapse in a feedback loop to steer the whole computation towards the right answer. So you gotta get this core idea down. Collapse is the compute. Recursion, just doing it again and again, that's the engine. And the feedback, that's the steering wheel that guides it. It's this beautiful, self-correcting loop. Okay, so that's the big idea. But how on earth do you actually build it? How do you make a machine that literally computes by collapsing? Well, it all comes down to this simple but super powerful three-step loop. Step 1, you let a quantum state evolve. Step 2, you perform a very specific, engineered measurement that intentionally collapses a part of it just to pull out a little bit of information. And step 3, a good old-fashioned classical computer analyzes that result and then retunes the whole system for the next go-round. And you just repeat that loop over and over, and the answer gets better and better with every single pass. And look, this isn't just some clever piece of software. We're talking about a whole new physical machine. It's a modular photonic computer, which is amazing because it can run near room temperature. Those feedback loops we talked about, they're physically baked into the hardware. It even has memory to keep track of past collapses to help guide future ones. The whole thing is designed to be scalable right from the get-go. Okay, I know this all sounds amazing in theory, right? Maybe too good to be true. Well, the simulation results, this is where the really meets the road. This is where we see it's not just some fantasy. All right, don't let these graphs intimidate you. The story they tell is actually super simple. On the left, that's what usually happens when noise hits a quantum calculation. It's just chaos. The signal dies. But on the right, that's the RQCE system in the exact same noisy conditions. And look at it. It's not just surviving, it's using that recursive process to actually steer itself towards a clean, stable final answer. It's basically thriving in the chaos that kills other systems. And what's so cool about this next chart is you can literally watch the machine learn. This line here, it shows the quality of the answer getting better with every single cycle. It starts down low, and then over 40 tries, you see it just climbing and climbing, homing in on the best solution. It's actively correcting itself in real time. It's amazing. And we're not talking about a little toy system here. These simulations have shown this working, this stable, self-correcting magic at over 1,700 qubits. I mean, that's a scale of stability that is just It's frankly unheard of in the quantum world right now. So, okay, we have this new way of thinking, this new machine. What does that actually mean? What does a computer that works like this unlock for all of us? Well, because of its unique hybrid design, it turns out it's perfect for a whole bunch of really practical, real-world problems. We're talking about heavy-duty optimization problems. Think logistics, energy grids, financial modeling. We're talking about simulating molecules to invent new materials. And maybe most excitingly, we're talking about creating these powerful new hybrid systems where AI and quantum computing work hand in hand. So if there's one thing to take away from all this, it's this. RQCE isn't just another team in the race to build more qubits or bigger shields. This is a fundamentally new category of machine. It really isn't about building a faster horse. It's like someone just invented the car. We're talking about a whole new racetrack. And it really makes you think, maybe this whole race for quantum supremacy isn't about building a bigger shield. Maybe it's about building a smarter engine. And that just leaves you with this one big question, right? What other huge fundamental assumptions are we all making right now that are just waiting to be completely flipped on their head?